All right, hello everyone. Welcome to MCLA and tonight's presentation in this semester's Green Living Seminar. I'm Elena Traster in the Environmental Studies Department. This semester's Green Living Seminar is organized around the theme of environmental pollution. All presentations are free and open to the public. They take place on Thursdays at 5:30 here in the Feigenbaum Center for Science and Innovation, room 121. Today's presentation will last about 45 minutes with an opportunity to ask questions at the end. And also a quick announcement for next week's presentation on Thursday, February 27th. David Bond from Bennington College will be presenting a lecture about PFOA in Vermont and New York. Today's presentation, Water Quality in the HOOSIC River Watershed, will be given by Matt Reardon, Environmental Analyst and NonPoint Source Program Manager with the Massachusetts Department of Environmental Protection, Division of Watershed Management. Thanks so much for coming today.
Okay, I'm Matthew Reardon. I'm going to give a brief talk on the water quality in the HOOSIC River Watershed. So before we I'll just talk about the structure of the talk. I'm going to do an overview of the watershed, give you some background information. I'll talk about some water quality issues. I'll talk about water quality resources, and then we'll have wrap up and questions. So just to set the context of where we are in the state, this is the Hudson River watershed actually, because the HOOSIC, the Kinderhook and the Bashfish, which is in the bottom left part of the state, all go to the Hudson River and in New York State. So as you can see, since I'm from Massachusetts, all of our watersheds end at the border. But we know that's not true. So we have some of the HOOSIC River watershed is in Vermont. Overall, the watershed is 204 square miles with 165 in Massachusetts. The elevations range from 560 feet at the state line in Vermont, where that mark is, to Mount Greylock, which is 3,487 feet. So you have two mountain ranges basically, the HOOSAC and then the Taconic, and then the Mount Greylock in the middle, and you have two valleys. So we have a lot of these steep tributary streams going into the main stems of the HOOSIC and the Green River. And that's just a thing I'll continue to talk about as we go on. So the headwater streams have very steep gradients. Some of them, like the Hopper Brook, the average gradient is 40%. So some of these tributaries are quite flashy when they flow, but the main stem itself is not. It doesn't have a high gradient. It's averages 19 feet a mile from Cheshire Lake, where the HOOSIC starts, to the USGS gauge in Williamsburg town. There's a lot of slope out here compared to a lot of the eastern part of the state. It's very flat. The mean basin slope is 19.5%. It's largely forested. This is a largely forested watershed compared to the eastern part of the state. And there's high pH to the geology. The geology here is dominated by carbonate rock with a mix of metamorphic and sedimentary. And so that affects the watershed, and I'll get back to that shortly. I was out sampling on September 11, 2007, and there was 3 inches of rain, and you can see the water just comes right up in atoms, and it was just shocking to me kind of just how quickly it filled up. This is in North Adams, this is the North Branch, but this is an awesome picture, but what happened was the entire stream was filled up, so bank full up to the banks, and it was within 3 hours. So that kind of surprised me because I was out sampling basically, for one thing, and safety-wise. But the second thing is just the power of the water. That year we put out these dissolved oxygen probes, and I said to the guys, just make sure you put a lot of rocks on it, really secure it, and oh yeah, it'll be fine. Allow them to move, because there's just, once you get these high flows and these flashy flows, it really moves things around. Okay. So as I was talking about the carbonate rocks in the area, I apologize for the graph. Right around here is 7 pH, right in the middle. And you'll see most of the watersheds in the state are kind of 6 to 7 as far as the median. I took a bunch of our readings, attended probe readings for pH, and I kind of put them all by watershed, and I figured out, I did these box plots. So right here, we have the HOOSIC and the HOOSITonic, and they have pHs close to 8 sometimes on average. So there's a lot of, there's high pH in this part of the state. And so for the students, and just anyone else, what's the positive effect of having high pH in your stream, do you think?
Counters acid rain.
Right, exactly. So acid rain, which had a lot of study in the 80s, but not as much now, like places like the Millers have very low acid neutralizing capability. So when there's acid rain, the pHs are very low in their streams. Yeah. Buzzards Bay is another one that also has low pH, and that's kind of the southeast part of the state. So, okay. We talked about pH. The other major thing is it's mostly natural, the land use out here. It's mostly forested. Only around 12% developed, and this is for the entire watershed, basically starting at the end in Williamstown. So this is everything. Agriculture is about 9%, and wetlands about 3%. The impervious surface in the entire watershed is around 4%. The impervious surface is basically roads and roofs, things that can't infiltrate water versus, like a farm field or something like that. So that's the general overview. So it's a largely forested, steep watershed with high pH. Okay. So can you guys see this well? Okay. So there's the idea of this river continuum concept. The idea of it is that as you go from a higher order stream, which is a low order stream, to high order stream. So if you go from headwaters down throughout the watershed, and as you gain streams coming in, they're considered higher order streams. They're farther down in the watershed. So basically, what this is a graphic showing this river continuum concept idea. The idea is that you have headwater streams. They're forested. They're cold. They have brook trout. They'll have slimy sculpin, and they have a lot of particulate matter going in through leaves. And then the invertebrates that are in the headwater streams will be a different type of functional feeding group. So the functional feeding group of the benthic macroinvertebrates is kind of how they primarily get their food. And there's a bunch of different types. There's shredders, grazers, collectors, and filter feeders. So at the top of the watershed, you have a lot of shredders, you have a lot of collectors, and you have some predators, which are like Megaloptera. Are those, if anyone's familiar with those are predators. And then as you go down, and so those are usually low nutrients, low productivity. There's not going to be a lot of algae because there's a forest around it, so it shades the stream. You might have a lot of moss sometimes. And then as you go down into the watershed, you get more grazers and scrapers. They're scraping the rocks for the algae, and collectors as well as prominent. And then, a lot of times what will happen is, so you'll have kind of the shredders and the EPT, and I'll get back to that in a second, in the upper part of the watershed, and then you'll have a lot of filter feeders in the main stem. And so you guys were talking about dams previously, and one of the things you see with the dams is they will increase the temperature of the stream, but they also oftentimes kind of like, if it's a large enough dam, there'll be algae growing, and then you'll find a lot of these filter feeding caddisflies right below the dam, and that's common. So there's a natural gradient of productivity as you go down the stream orders from not very productive in the headwaters to more productive the farther down you go. And the productivity means basically there's more algae, there's more of that going on. Oh, as you get farther down, so the shredders, they get rid of the leaves and things like that and kind of utilize those. And as you go into the main stem, there's fine particulate organic matter, which is smaller in the water column. So just keep that in the back of your mind with all the slides I talk about throughout this talk, just this river continuum concept. All right. So water quality issues include pathogens, which is E. coli bacteria, nutrients, habitat alteration, and dams in fish passage. That's that. So before I get into the current day, I just wanted to show this slide, 1968, to show you kind of like how far we've come with the Clean Water Act in terms of we have more advanced treatment plants, wastewater treatment plants now. So this is beginning in the Cheshire Reservoir, and as you go down to North Adams and Williamstown to the left. So you can see basically as you came from Cheshire into the kind of developed areas in Adams and North Adams, the dissolved oxygen has dropped off, and it's almost near zero, very low. So that would have been very bad for aquatic life, for fish, for invertebrates. And you'll notice the fecal coliform has a similar type of pattern, but the opposite. It starts in Cheshire, and as you get more developed, it was much higher. It goes up. It keeps going up. Those numbers are, for the fecal coliform, 10,000 per 100 milliliters. So we're much higher. Like, these are very high numbers. We don't see anything like this nowadays, unless there's a sewer pipe that literally broke open into the stream, that kind of thing. It's also interesting that kind of once you hit North Adams and the North Branch came in, things kind of got a little bit better on those, it seemed like. So there's two different ways that we kind of evaluate bacteria data, E. coli data in Massachusetts. And there's the primary contact use, which is basically swimming. And there is a secondary contact use, which is basically just fishing and just incidental contact with the water. And we take a bunch of samples, and then you calculate something called the geomean. And if the geomean is above 126, you fail the primary contact use. If it's above 630, you fail the secondary contact use. So I won't get into all the details. The standards the water quality standards are there's a draft out right now, and these things may change. But you can, if you're really curious, you can kind of look on our, just Google it, Mass DP water quality standards. So those are the two ways that we determine things. So this is the geomean of the data I collected in 2006. So what you'll notice is I colored it by green to kind of red if it's above 126, which is the primary contact. So what you'll notice, though, is basically you have the tributaries are green. Not so bad. They're below the standard mostly. And as you get into the urbanized areas, in Adams, North Adams, and into Williamstown, you have 225, 260, and 195. And then it's just below the standards up past the treatment plant in Williamstown. So that is basically a normal thing in terms of this watershed. Where there's development, you have higher bacteria numbers. So, and part of that is infrastructure. And this is common throughout Massachusetts. We have old infrastructure. So a lot of times there will be two troughs, and one will have stormwater and one will have sewer. And if there's too much water getting into the sewer pipes or the stormwater pipes, you'll get kind of the water will get from one trough into the other, basically because of overflow, and then you have kind of sewage going into the stream. And then you also have something called illicit connections, is when people take their septic system and they just connect it into the storm drain, and then you have that happening. So those are common things that happen. I think at one point Dan Karpaska, who may have come and talked here before, he found a couple of those kind of connections in the watershed. You know, they weren't. One of them I think was a car wash, where the floor drains were into the stream. So there's a lot of old infrastructure, and people, you know, they just built it, and we don't really know what lurking. So I took some of there's a gentleman here from Hura. I took some of that bacteria data that you guys collected in 2007, and I did the geomean for those samples, and you'll see this was all in the Green River, which is on the other side of Mount Greylock. You'll see it starts out 13.7. It's very low geomean of E. coli, and then as you go downstream, it kind of increases a little bit to about the 90s, and then it's 78 in Williamstown itself. There was a Williamstown student that did a little study on Christmas Brook, naughty or nice, and he did a bunch of E. coli testing, and I think they fixed a lot of those things downtown in Williamstown many years back. This is probably like 2008 to 10, and so the Green River is doing pretty good. It's meeting the standards right now, according to that data. So the other big thing in freshwater systems is nutrient pollution, and the primary concern is phosphorus. It's a big problem in lakes, and it's a big problem. It's a little bit of a problem in our rivers. So this is all of the sites from 2007, and you'll notice most of them are below this line. This is 0.025 milligrams per liter of total phosphorus. So a lot of these are quite low. And then 0.05 is right here. So the HOOSIC River, Hodges Cross Road is just above that a little bit. And then HOOSIC River and Ashton Avenue, which is in between North Adams and Williamstown. And the HOOSIC River and Williamstown, which is almost out of the state. Those are kind of in this middle zone here. But I want you to note this one and this one. Those are 1547 is the headwater stream Buxton Brook, which is in Williamstown. And 1553 is East Branch Green. So you'll notice that these two headwater streams are very low in phosphorus. Very low. So this is just a graphic of those three three ones that were higher on the graph. We have the HOOSIC River in Williamstown. We have the one that's in between the two at Ashton Avenue Canoe Launch, and then the Hodges Cross Road. So there's two major types of pollution and how we kind of classify them. One is called the point source, and so that is basically something that has a distinct pipe, and that could be like a wastewater treatment plant. And then there's non-point source, which is something like fertilizing your lawn or agriculture. It doesn't have a pipe, or that's just kind of how we talk about them in our kind of governmental world. So you learned about chloride last week. So this is the HOOSIC River downstream from the HOOSAC wastewater treatment plant. So you're thinking about the river continuum concept, and what do you notice about this stream, this river here? Or what do you notice about it at all, I guess I would say?
It's wide.
It's wide. Yep. Yeah. You really can't tell from the aerial perhaps, but it's 100 feet wide there. And so there's less shading. What types of things do you think might affect how much algae is on the stream bed? Sunlight.
Temperature.
Nutrients.
Temperature sometimes. Nutrients for absolutely. Yep. And the other thing sometimes here is scour. Like I would go out. When we did sampling. If you had a really high flow, it would just scour off the rocks for the algae. It's interesting. So So that's sometimes if you have kind of a drought, even in these kind of pristine areas, you'll get buildup of algae because it just isn't getting scoured away. Okay, so this is the same site. Oh, this is the HOOSIC River, and this is the dissolved oxygen probe. And we put out a dissolved oxygen probe on 3 occasions in 2007, and these are the graphs. So what do you notice about this graph?
Cyclic.
It's cyclic, right? Exactly.
And many times it goes down.
Yep, absolutely. That's what's happening. And given the fact that it's a wide stream, and we know it's farther down in the watershed, we have a lot more indication of productivity here. These are pretty large swings of dissolved oxygen. And I will compare them to the headwater stream shortly. But they went from about 5 to 6 milligrams per liter over the course of a day, which is quite high. And the highest range for the saturation of dissolved oxygen was about 145%. So that means there's a lot of oxygen in the water. The one thing I will note that we did benthic macroinvertebrates in 2002 and 2007 at this site, and they got better in 2007. So that's kind of nutrients and productivity. We have one site where we kind of see some indications of productivity. And next I'll talk about habitat. So there was a hurricane in 1938. There were 7 inches of rain over 3 days, 2 deaths, and 300 were left homeless. And then in 1948, they had a similar large storm that caused $1.2 million of damage in North Adams. And this is kind of an old photo of like a stream basically going through the road in North Adams here. So understandably, people were kind of obviously, that was a big traumatic event. And so they asked the Army Corps of Engineers to build these flood control chutes to prevent the flooding like this. So this is what they look like. So what do you notice about these photos in general? Shallow. What effect do you think being shallow might have on raises temperature? The other thing I would notice is that, so one of the things when we do fish sampling, we say, okay, how's the habitat? Are there places where a fish could have refuge so that it's not just out in the open? And so we judge that based on kind of boulders to hide behind. The stream banks sometimes will be undercut with some roots over it, and they can kind of hide out under there. There's a variety of habitats, riffles and pools. This is just one kind of shallow area. And you don't have the normal, riffle's a shallow, fast spot, and then a pool is a deeper area. So you don't have any riffle pools, and that's kind of important for a stream. And then the other way in which we often straighten channels with riprap. And similarly, that has the issue of you just have a long riffle versus a normal pattern. And in a normal stream, maybe not in headwaters, but in other areas will have meanders, and it won't be just straight. So the straightness will mean higher velocities. It's not as great. And then the other kind of habitat issues you sometimes have, so this is Hodges Cross, and you have the flood chutes all through here, and then you have this agricultural kind of field area or this field area. And so one of the things that has been studied with geomorphologists who study this more, and just general straightening of streams, is that once they get past that straightening point, they kind of, all that energy has to go somewhere, and it erodes the stream just below it. It makes those banks unstable. So these are some photos of, this is a photo downstream of the bridge there, and you can kind of see some erosion of the bank. The other thing is there are no trees there, so there's no trees stabilizing the bank. A similar kind of erosion happening there as well on the banks. So you read about dams. This is all the dams in the state. Can anyone guess how many dams there are in our state? 2,903, I think it is. Yeah, it's unbelievable. So in addition to just kind of the flood storage and the kind of, I want to make a lake, a lot of these are just old mill dams that were built for industry. A lot of them are that. There was one in Amherst where they took out the dam. They did a Division of Ecological Restoration, took out a dam to restore the stream. And then after they took out the dam, the stream kind of eroded away all those sediments behind the dam. And then they found another wooden dam below that dam. So anyways, so there's a lot of them, and they just came out of nowhere, I guess. There was one up in Clarksburg that they took out, Division of Ecological Restoration. So that's good because I think there's long-nosed sucker fish up there, long-nosed sucker, and they're pretty rare. So that was good. The other issue besides dams, so dams obviously are affecting fish passage, the fish's ability to move. But here's another picture from Bentley Brook in Hancock. It's in I think it's in Bash Bish or it's in Kinderhook. So what's the problem here? Yeah, fish have to jump. So these are perched culverts. So, if you're a fish, you really can't get through there unless it was an amazing flood and you just got pushed through. So in the summer, you're not going to be able to move along the stream. So there were some guys at the Conti Fish Lab. They've done studies of brook trout, and they looked at the genetics of the brook trout, and they were trying to figure out whether or not dams were kind of isolating the different populations of brook trout from each other. So the main things were bacteria, nutrients, habitat-related issues, and dams and fish passage. So then I want to tell you about all the good things that are going on in terms of, as I talked about in the beginning, it's a highly forested watershed. These are pictures of brook trout in Williamstown. It's actually like right downtown near East Lawn Cemetery. There were some actually large brook trout there. And it's a little, because it's, fairly built up, I guess you could say. But we found some really large fish there. So we talked about headwater streams, and we talked about them having less nutrients, and they also are cooler. So what we often find in headwater streams is there's a stonefly. It's in the peltoperlid family, which is the roach stonefly. And I'll show you, it's right here. And this one's called Taloperla. And you often find these in headwater streams. And they are kind of cold water taxa. And you often find them, just like brook trout, they have a similar kind of temperature tolerance, like right around here. And above 20, they drop out. So we consider cold water fisheries in terms of temperature having temperatures below 20 degrees Celsius or 68 degrees Fahrenheit. Once they get past that, they can kind of keep going, the eastern brook trout, past 20, but once 21, 22, once you get past that, they're not doing good. So we use benthic macroinvertebrates to determine stream health. There's three main orders: Ephemeroptera, Procoptera, and Trichoptera. That is mayflies, stoneflies, and caddisflies. And the number of those you find in a watershed is a sample is often indicative of the water quality. So the higher the number, the better the water quality. And these are stoneflies, the Taloperla. The Taloperla, they're also shredders, like I talked about in the beginning of the talk. I talked about the functional feeding groups and how shredders are often found in the upper part of the watershed in the mountain streams. So that's all the locations in Massachusetts where we found the peltoperlid or the roach stonefly. Now this doesn't mean that there aren't roach stoneflies other places, but this is of the places we've sampled. These are the places we found them. So as you see, basically, and you'll see this through the rest of some of the graphs I show you. Eastern part of the state, much more developed, a lot more population pressure and just development pressure. And so the streams, the cold water streams, a lot of them have dropped away, if they were there at all. And so you don't have the temperatures to kind of, they can't tolerate the temperatures in the eastern part of the state. And so this is the Buxton Brook. We found the roach stonefly, Peck's Brook, and East Branch Green River. So what do you notice about Buxton Brook here compared to our previous image of the HOOSIC River? It's narrow. Yeah. It's not straight. Someone said shaded. There's more trees. They're very close to the stream. So this right bank is pretty good. The left bank is, and this happens a lot, you'll see it everywhere around here, is, the road is next to the river because that's the low point, and it's easy to put the road there. So there's a road on the left bank, and on the right bank is forested. So one of the things we do when we do the macroinvertebrate sampling is we look at the habitat, the variety of habitat, the riffle runs and the pools. And we also look at, are the stream banks eroding? Is there good cover on both banks? How far back does it go? So the right side here would be good, but since parts of it are near the road, we kind of score that a little bit lower. It's not as good habitat. But overall, it's cold and has low phosphorus, as we talked about earlier. So this is brook trout in Massachusetts. I took all the Department of Fish and Game sampling points, and I figured out which ones had brook trout. So this is where they've sampled and where they've sampled in the summer. So that's kind of the, I think I have the sense if they're out of Westboro or depending on where they're out of, and they may have not gone to every part of the state. But kind of see the similar pattern as before. Highly developed areas, much less brook trout, and much more of it in the western part of the state, central and western part. There's also some sea-run brook trout along Cape Cod, and I think Martha's Vineyard has one too. So coinciding with the brook trout distribution are the stream temperatures. I took some of our temperature data, and I just kind of classified it. The snowflake is really cold, and then the little fish that says good is okay for trout, and yellow is fair, and pink is poor. So you see a similar thing here where the temperatures are usually too high for a lot of these streams in the eastern part of the state. The coldest streams are on Cape Cod. Cape Cod has sandy soils, and so it all just infiltrates, and they have much more constant, they have like a constant flow of water a lot of times. Like sometimes it'll rain, and you don't, like you saw in the beginning graph, that hydrograph where the flows went up high. Sometimes it'll rain there, and you hardly see the flows, going up much because it just goes into the groundwater and it kind of slowly bleeds out. And so the effect of that is they have more constant flows, and they tend to be quite cold along in the Cape Cod. But the other area is the HOOSIC and Housatonic has cold temperatures in the streams. All right. Here are all the locations in the HOOSIC River watershed, in the Kinderhook, where we found brook trout. So what do you notice about this, if you notice anything in terms of the distribution?
Nothing in the main stem to speak of.
Right. All right. So these are taken during the summer, these samples, most likely. And so, the main stem HOOSIC may get utilized in between in the fall and spring by brook trout, kind of moving along from place to place. But you don't often see them in the main stem of the HOOSIC in our samples. The Green River, they're throughout the Green River and watershed. Yeah. So Buxton Brook has it, East Branch Green has it, and Peck's Brook. So those three mountain streams I talked about with low pH shading. So we saw the HOOSIC River, dissolved oxygen, lots of swing over the days. Now we're going to look at Buxton Brook, our small little tributary stream. So we had 3 deployments in 2007, and you have very high dissolved oxygen, above 8. And you don't see much of a diel pattern at all. It's just high. So what does that tell you?
It's cold.
It's cold. When we talked about the river continuum concept and less productivity in headwater streams and more as you go downstream. So there's a lot less productivity because it's shaded, it's shallow, low nutrients. You don't have algae or plants producing a lot of oxygen during the day and then it going down at night. So Buxton, I didn't have a temp logger there, but I do have one at the East Branch Green. And you'll notice it's all below 20 degrees Celsius. So this was one of the other small tributary streams. From 627 to 1025, it's quite low, below 20. So that's good. All right. So that is why we see the peltoperlids and we see the trout there, because these low temperatures they can tolerate. So some good student projects if you guys are interested. I don't know, are you guys all seniors or no? Okay. All right, so you got some time. You could deploy a conductivity sensor and then you can measure chloride and see if there's a relationship. Now, like I said, you want to make sure it's really well secured so it doesn't get destroyed if you put it anywhere near the main stem or even the tribs. You could do some bacteria source tracking. Dan Karpaska, who works in our western region, used to be a bacteria source tracking for our state. And those positions kind of went away, but that's basically going out and seeing if you can figure out where there's hot spots and trying to find the sources. You could pick a small watershed and create a watershed-based plan, and I'll tell you about that tool shortly. Department of Ecological Restoration does stream crossing surveys. You could go out and find places like that perched culvert I talked about, and you could do a survey for them, and they could put it on the list. And they have they have a grant program. I think that $800,000 a year to replace culverts, and in addition to the fact that you want to have the wildlife be able to move, when you have those perched culverts, sometimes they get clogged up, and then you have flooding upstream, and people don't like that part of it. So there's habitat benefits, and there's also kind of just flooding benefits. So you guys talked about road salt last time. One of my coworkers, Dr. David Wong, he looked at all of our connectivity data, and he also looked at our chloride data. And there's 2 EPA thresholds for chloride, 230 milligrams per liter and 860 milligrams per liter, acute and chronic. So acute is obviously 860, and 230 is the chronic concentration. So basically, it's okay out west, and it's a little bit more elevated in the east. So these pink areas are chronic, and then the red ones would be considered acute. And so when he took the connectivity information and he took the chloride information, he created a regression relationship between connectivity and chloride. Yeah. So you can use this to kind of predict what the chloride would be in the stream without having to constantly test. The best way he put some probes out in a stream near Chelmsford, and he had a continuous connectivity, and then he would occasionally take chloride measurements or take chloride samples. And that's the best way to use this. If you have a continuous record and you can interpolate in between, what the chloride numbers are, and you can see what happens. And what he found, not surprisingly, is when it snows, we put a lot of salt down, and then the conductivity goes up. Sometimes to acute levels, actually, in that one stream. Because it was near 495 and some other major roads. Right, so this is just showing you kind of where on the graph the 230 would be and where the 860 would be in terms of conductivity. So here are some resources. We have a thing called the Integrated List of Waters. That's what where we tell people, how things are going in terms of water quality for different streams, whether they're supporting or impaired. So that, if you're interested, you could look at that. We have a web page with water quality assessments, and there's some older reports there. The consolidated assessment and listing methodology, Appendix F, has that regression equation from chloride, for the chloride. And it also basically tells you all the rules and how we kind of say, okay, for primary contact, secondary contact, and what class of water it is, how we make our decisions. That's all there. You can just Google Mass DEP 319 or 604B. Those are the two grant programs that are under me. We have the 604B grant program deals with water quality assessments, figuring out what the problems are. And the 319 grant program deals with kind of implementing best management practice to fix the problems. So that could be stormwater BMPs, or it could be work on farms to prevent the pollution. We also have the watershed-based plan tool, and it allows you to kind of pick a watershed, and it will bring in all the information that we have on it. And it also will do some calculations for how much load of phosphorus, nitrogen, is coming off the land, and that's based on kind of like the land use. Each land use has a different loading coefficient. And at the end, it gives you, okay, this is the load of phosphorus coming out of your watershed. And then it also gives you the ability to kind of pick BMPs and try to fix certain problems. So there's like pick menus to do that. And then the last link is for the Department of Ecological Restoration, their culvert replacement program. So I sent the link to Dr. Traister. This is some of our seasonal summer help. There's a guy, Sean, with a fish there. And so basically, you should think about applying if you're interested. You're a student. Yeah. It's not a bad way to spend a summer.